Which kind of takes us to this next example. Do you see an inside? Do you see an outside? Let me help you to see it, okay? I would imagine, and I hope that you feel like 4x cubed minus 1 is on the inside. Usually people feel like that they can be confident of that, but the outside, when I say that, I'm not referring to the x squared. You guys will actually come to learn, and I'd like you to start to think about it today, that that actually is there as a sacrifice. It's going to cancel. So this is not the outside. This is actually meant to cancel. 1/2 square root. That's the outside. Now there'll be a point, maybe that point's already come. Maybe it'll come sometime where you don't have to rewrite it, you just think 1/2. So again, the square root is the outside function, otherwise known as a 1/2 power. What's this whole u thing? The whole u thing is to create a simpler integral. So when I say u is going to equal the inside, when I say u is going to equal 4x cubed minus 1, eventually that's going to get substituted in there. But I have to do this little song and dance over here. I have to do the derivative thing. And yes, you're going to be doing derivatives and antiderivatives in the same problem. So you want to kind of keep it straight. Okay, good news. A lot of times it's a simpler derivative. I hope that you're just bringing the exponent down, but you're subtracting from the exponent, right? Derivatives, you subtract from an exponent. And we do the derivative of this x, and that gives us dx. And I kind of thought of, in case anybody was wondering, it's like you're separating. You're separating the du and the dx. Okay? But really, the reason you're doing that, as you're going to come to realize, is what you really want is you want to solve for dx. You want like a dx expression. So yep, you divide x squared. Yep, you divide 12. I mean, I can write it a little nicer for you as 1/12 x squared. Now, there's two things up here that are sort of just screaming, substitute me. And it always works this way. There's two, we'll call them expressions, that want to get substituted into this integral. And when they do, you end up with something simpler. You end up with something that's going to cancel. And you will pick up on some shortcuts, and some of you will eventually do some of this stuff mentally, but for now, it's a great idea to rewrite anything that doesn't change. So x squared doesn't change. 1/2 is still there. Okay, but 4x cubed minus 1, now that becomes u. That becomes u. And then dx, okay, and you'll find out this is really the heart of the problem. This dx thing becomes this thing. It becomes this 1/12 x squared du. And you understand what I mean when you finally get this. And you will. At least that's our goal. You will understand what I mean when I say that the du, or excuse me, the derivative of u, which was equal to 12x squared, that du, obviously it got rearranged, but it was meant to cancel. It was meant to cancel with the rest of the problem. Again, this 12x squared, I know I got it back here, and I know it now in the denominator, but the whole reason that happened was so I could cancel out those x's. Okay, and I'll call that like a cancellation connection. A cancellation connection. And sort of when all the dust settles, out pops a simpler, doable integral. Now here's the other thing. I didn't actually do any antiderivatives yet. Like if you really think about it and you look at where I started and where I am, I've simply changed the way this thing looks. But I did not actually change the function, meaning I did not actually add to the exponent. I did not actually divide by the new exponent. Now, the reason I'm saying that is because you need to do that. You need to do the antiderivative. And that'll also be a step that you'll hear me say again, because that is sometimes forgotten. You do all this stuff over here. I know it looks crazy, but then you never actually change to the antiderivative. So add to the exponent, divide by the exponent. Do a good job with exponents. So, dividing by 3/2 is the same as multiplying by 2/3. Doing good stuff like that can save a lot of pain and suffering. Oops, I actually wrote something slightly wrong. Technically, it's a U. I had an X right there, but technically it's still a U. Okay, because of course that's what I've changed the function into. 1/12 and 2/3, like it or not, you got to do a little bit of simplifying. So basically we get a 1/18, 1/18. But this U, it needs to get turned back into what it equals. It needs to become a function of x. And of course, it's equal to 4x cubed minus 1. So I have 1/18 of 4x cubed minus 1 all to the 3/2 plus c. As I said near the end of the period or the end of the half period, if you check your answer, if you do the derivative, if you go back to where you started, you'll see that it works. Okay, basically 3/2 times 1/18 is going to do a little canceling and simplifying, and then eventually I will do the chain rule, which will be the derivative of the inside, and that's how we end up just with x squared, and of course to a 1/2 power, because I'll subtract from this exponent. Okay, we don't sort of check every problem, but technically every problem will check according to the chain rule. Now we did 2, and I know you might be at some different spots, but we'll just kind of pause here, step back a little bit. I'm going to show you some steps. If it helps you to write them down, if it doesn't help, just read them. But you do kind of follow these steps every time. You let u equal the inside of the function. You let u equal g of x. Again, let u equal the inside of the function. You'll always do the derivative of u. You'll always do that little sidebar of calculus. So you're going to do the derivative. Now it says here that sometimes it's helpful to rewrite that equal to dx. So far, that's what I've done for every problem. I have solved it for dx. You will find out why I say sometimes, because there'll be some times where you might not need to do that. But the bottom line is you're going to find or let u, and then you're going to find du. You're going to do the derivative. You're going to substitute them back in. You're going to substitute them back in. Stuff should cancel. In fact, x's should cancel. And if they do cancel, then you have figured out what I call the cancellation connection. Okay, and now you should have like a simpler function. You should have a simpler function. Now, just so you kind of know when I say it again, that you realize, because it's something people forget, these three steps, there has been no antiderivative yet. That's fine. You should not have done the antiderivative yet, but you have to finish the problem with the antiderivative. The reason you did these three steps is so you can actually integrate. So you can actually do the antiderivative. And trust me, we'll be at a point in some problems that are so tricky that you'll feel like you already did all the work, but we'll go back to this and we'll say, remember, you got to do step 4, you got to integrate. Let's do just one more problem today. I definitely want you to feel like you're starting to catch on, but I also want you to be exposed to a problem that doesn't seem to kind of fit just so perfectly this idea of an inside and outside. And yet, I hope you realize it still does. It still has an inside and outside. So I got the integral of 4x over x squared plus 2. Okay, now I'm going to do something here that for some of you, you're like ready for this. You might not realize you're ready. Some of you might not realize though why I'm doing it, but in a day or so, you'll come back like, I know why you did that. But I want to take you through a little bit of a what if. What if we choose u to be? In other words, what the heck is the inside of this? You know, it's got a numerator and a denominator, so which one's the inside? Don't write this down yet. Just watch. Okay, because if I let u equal 4x, okay, if I let u equal 4x, then the derivative of u, I'm going to say, is just 4 dx, but it's just 4. Now, this is going to become u, but that means that this is what we call the rest of the problem. Now, that x squared plus 2, whether you realize or not, it needs to cancel down the road. But the problem is that down the road, the only thing I'm going to have available to cancel is like this 4. And even if, again, you're not completely sure, you have to say, well, how in the heck is an x squared plus 2 going to cancel with a 4? It's not. It's not, because we did not choose the correct u. We did not choose the correct u that has the correct du that'll cancel with this. Okay, now, what if you do it the other way? What if you let u, and this is the right way, so if you want to write it down because that helps you, then I would encourage you to write it down now. What if you let u equal x squared plus 2? Listen, this is the thing. I don't want you to like worry about it, but soon you're going to get this. What are you going to get? You're going to get that the derivative of u is supposed to cancel with the rest of the problem. Now, the derivative of u, let's just get it right. It's 2x dx. If I let x squared plus 2 be u, that means this is the rest of the problem. Okay, that means the numerator is the rest of the problem. Down the road, I want this to cancel. And what I really want to cancel is the x. You guys will learn that the numbers don't actually matter. numbers can change. I erased some of it, but we had like 1 over 18. That's fine. But this x is what's got to cancel. Well, guess what? It's going to cancel nicely because the derivative of u gave us or created an x. Okay, when I say x, I mean like x to the first power. Let's see the cancellation. Let's sort of watch this happen. At this point, I'm still going to kind of follow what we've done a couple times. Maybe, just maybe, you're saying, yes, I realize why you're doing that, because, well, when it's 1 over 2x, then it's going to be able to cancel with this 4x. Okay, and that's technically why it cancels, because now I'm dividing by this 2x. I wonder if you want to substitute. Do you want to think about it before I write it down? You should feel like these 2 yellow boxes are being substituted. You really don't have to think too much right now. You can just follow the sort of the process. Now, that means that this 4x, nothing changes, but it does mean that the bottom becomes just u. I know, it seems kind of strange, but yep, it's just u. This dx becomes this 1 over 2x du. Okay, again, this is the point, and once you get this, you'll realize that x was there to cancel. That's the point where we understand really why the substitution method works. So x is gone, bye-bye x, 4 over 2. Okay, 4 over 2 is 2. 2 over u, 2 over u du. I'm not going to call on anybody, but you guys realize that you should know how to do this antiderivative. It can look a little different because it's got the letter u. It also can look a little different because, honestly, it's actually so simple. Again, don't get anxious. I'm not going to call on you, but do you know how to do 2 over u? Do you know how to do 1 over u? See what I did with the 2? You can kind of do that mentally. Good. Now, 2 ln of u. I'm being kind of like technical here. It's 2 ln of u until or before I actually do the final substitution. Now, there might be some of you, again, sooner than later, you're going to be like, wait a minute, I don't really need to write u. Yep, you don't really need to write u. You could say, isn't u just going to be x squared plus 2? I don't want to get ahead of us, but I'm just sharing, when you're ready to do that, you don't need my permission. You can. Is that what you were going to ask?
Yeah.
You just did the chain rule backwards. If you do the chain rule forwards, you would do the derivative of this, and you would see that it's going to turn into that. Okay, but we just did the chain rule backwards. It's called substitution. I kind of want to start with this tomorrow, but that means I can still show it to you today. When you get this, you're going to understand that you always choose u, so that du cancels with the rest of the problem. You'll realize that you can do the substitution steps 1, 2, 3, 4, but it's about choosing u. And I want to keep helping you understand this so that du will cancel.